Now, what is the Gauss theorem? Its statement is, the Gauss theorem states that surface integral, like this is an integral, and I put it here S. S means surface integral of electrostatic field, like E vector. E vector is electrostatic field produced by any source. Any source mean like that the source is a charge Q. Okay, because of this Q charge there is an electric field. So the surface integral of the electrostatic field E produced by any sources mean like Q, and our any closed surface, so I put it here closed. Okay, closed surface S like that here this is a closed surface S and there is a charge Q inside, and enclosing this surface is enclosing a volume V. Okay, then total electric flux. You know what's the meaning of the electric flux? Electric flux is E vector dot ds vector. Okay, E vector dot ds vector integral over the closed surface. This is electric flux. Then total electric flux over the closed surface is, and I am talking in vacuum, it is equals to, by the statement of the Gauss theorem, it is equals to 1 over epsilon naught times the charge. Okay, the charge contained inside the surface S. This Q charge is inside the surface S. So very simple. This total flux through the closed surface over volume V is 1 over epsilon naught times the charge enclosed. Now keep in mind one thing. The charge inside the S is maybe a point charges. This may be a point charges, or even maybe here the continuous charge distribution. Okay, and further the location of this Q is like that at here, or Q is at here, or Q is at here, does not affect the value of the left hand side. We have whatever the position of Q inside, no problem. The flux will be only 1 over epsilon naught times the charge enclosed. That's the Gauss theorem statement. Total flux is 1 upon epsilon naught times the charge enclosed. Okay. Now next it is if our surface, this surface, it contains point charges Q1, Q2, Q3 lying inside the surface, then what will be the total flux? Then total flux phi E will be equals to 1 over epsilon naught Q1 plus 1 upon epsilon naught Q2 and so on. Okay, that is 1 upon epsilon naught Q1 plus Q2 and so on. So you can say 1 upon epsilon naught, right? I equals to 1 to n Qi. That means summation means sum. first of all q1, then plus I equals to 2 q2, then I equals to 3 q3. So that's it is. So this will be the total flux if there are many number of point charges inside the surface. Okay, then flux will be simply the algebraical sum. If one charge is positive, other charge is negative, then minus sign is also taken into consideration. This is very important. Now there is an application of the Gauss theorem. If we are having a line charge, okay, infinitely long, thin wire means on this wire just a single charge is lying, plus plus, only one charge is lying at one point. That means thin, infinitely thin, long, thin wire, and uniform linear charge density. Linear charge density means lambda. That means charge per unit length. Charge per unit length is called linear charge density. Okay. Now we to consider the electrical intensity here because of this infinitely long thin wire. Let you consider a small element P1, and because of this small element P1, charged element you can say, and put it here a unit positive charge. So this charge, because of this charge there will be repulsion and direction of E will be along this side. Now just resolving E1 into components, one component along this side, another component along this side. Now you consider this element, and this is positive element. Put it here unit positive charge. The positive charge will go along this side. Again making the component of E2, one along this side, other along this side. Now because of the two elements, this component and this component will cancel out, and these two components they will add up. So I mean to say, because of the two elements S, the direction of E is along this side. So there is the same explanation. Because of the every element of the thin wire, the direction of E will be perpendicular to the x-axis. If this is x-axis, then E will be along the y-axis, perpendicular in direction. So let me consider a Gaussian surface, of a cylindrical shape. This is our choice. Selection of the Gaussian surface like this. How many closed surfaces are there for this Gaussian surface? So there is one cap, there is another cap, and one this curved surface. So there are the three, you can say, three closed surfaces for the cylindrical Gaussian surface. So we write down the Gauss theorem, S E dot ds is equals to 1 over epsilon naught times the charge enclosed. I already defined lambda. Lambda is charge upon length. So we consider the length from here to here, that the length L. Then the charge enclosed by this cylindrical surface, charge will be equals to lambda into L. Okay. Then this charge is Q, which is enclosed. So it is equals to lambda into L. Now dividing this surface into the three parts. Okay. One is this cap, let me call it C1. C1 E dot ds plus this gap, let me call it C2. C2 E dot ds plus third part, which is the curved surface of the cylinder. E dot ds. I call the curved surface of the cylinder like S dash, because S is for total surface. Total surface having three subparts, C1, C2 and S dash, and equals to, by Gauss theorem, 1 over epsilon naught into lambda L. Now just what is the dot product between E and ds for C1? This is C1 now. Electrical intensity I already explained. If unit positive charge here, it will be along this side. And area C1 perpendicular and outward. The angle is 90 degree. If you consider point here, this will be the E upward, and area is along this, angle is 90. So here cos 90 dot product, cos 90 is 0. So this contribution is 0. Similarly for this gap, E is along this side, area is along this side, angle is 90. Okay, E is along the y direction and area is outward, angle is 90. So this contribution 0. We left only one curved surface where E and area both are along the same direction. So dot product means cos 0, cos theta, and here for curved surface cos 0 is 1. So here left only E into ds, S dash. S dash means the curved surface of the cylinder. It is equals to 1 over epsilon naught into lambda into L. What is the total surface area of the cylinder? So if this radius is r, then surface area becomes 2 pi r. 2 pi r means circumference into the length into L is 1 upon epsilon naught into lambda into L. LL cancels. So E becomes 1 upon, here 2 pi epsilon naught, 2 pi epsilon naught lambda upon R. So this is the final source of electrical intensity due to the infinitely thin wire at any point. So it will be perpendicular along y, and it is 1 over 2 pi epsilon naught lambda upon R. Okay. So E is equals to lambda upon 2 pi epsilon naught R. Mean electrical intensity for the linear charge, infinitely long linear charge at any point here, if this distance is r, then electrical field only a function of r. If r is less, E will be strong. If r is large, E will be weak. So E depends upon the distance of the measurement of E from the line. Okay.